Okay, so welcome back, and now what we're going to do is just reiterate some of the things that I talked about in the beginning of this section, was on the idea of the restricted values and when we can use these inverse functions. So this is what we're doing. So again, we can compose these two functions and we'll get x. So these will undo each other and give you x for this range, right? For this domain, this restricted range. Likewise, you can compose cosine and inverse cosine to get x for this domain, okay? And so again, tangent composed with inverse tangent over this domain, okay? Now notice that the restricted range of values for x, the domain, is restricted by, so again, we're looking at a composition of functions. So remember, the composition of functions, the domain is comprised of the intersection of the domain of the individual function. So it's, in this case, the sine function has a domain of the sine function has a domain of pi over negative pi over 2 to pi over 2, but the inverse function of sine has a domain of negative 1 to 1. Okay, so since the domain of this function is smaller, right, is inside the domain of this function, it's restricted by this. Okay, so again, when you look at a composition of functions, the domain is going to be restricted by the intersection of both functions. Okay, or in this case here, it's restricted by the function of the inside function. Okay, and notice that when we swap them, right, so we have sine composed with inverse sine, and here we have inverse sine composed with sine. So here we have sine circle inverse sine, here we have inverse sine circle sine for our composition. And so notice how the domain changes. Okay, so again, make sure you understand that. Okay, so if this is correct, if these are satisfied, then we know that this will always be true, and then we can use that to solve problems. And that's what we're going to do next. We'll do some examples. Have a great day.